Amino acids in solution at pH 7 are predominantly dipolar ion. Like this one here, we see that this is a dipole because we have a plus minus charges. The ionization state of amino acids varies with pHs. We have seen that in the previous video. But we also have to look for, is there any chance that these charges are going to balance out, even though when we have side chains that are positively charged like lysine or negatively charged like aspartate? The answer for that is a yes. We define that point as the isoelectric point because they have the same value and number but different sign, so there will be a net charge of 0. These amino acids, those that are hydrophobic, alanine, leucine, and valine, have an isoelectric point very close to 7, which is pH about 6.0. The basic amino acids will have basic values like a pH 7.6 for histidine, that will be the isoelectric point. And then you will have lysine 9.7, arginine 10.8. Those are the basic amino acids. And the isoelectric point for acidic amino acids are very low because they are acidic. But what is the meaning of that? If you have a solution, let's say of glycine, this is glycine because we have that the alpha carbon is attached to 2 hydrogens. Glycine has 2 different groups. It has a pKa, that is how acidic this group is 2.34 for the carboxylic acid group, and the pKa value for the amino group is 9.6, which indicates that this group is an acid and this is a base. That's something very straightforward. But if you have a solution of glycine and you start titrating that solution, at the beginning, before you add loss of the solution of sodium hydroxide, it will look like you have the carboxylic acid group will be protonated if it's a very low pH. If it's a pH that is below 2.34, that carboxylate group will have the hydrogens. We will have the 2 hydrogens and the amino group, and then you continue adding base, and there is a point where you will add, if you add too many moles of the base, you will have the carboxylate group in one side and you have lost the hydrogen, so you have glycine with 2 different ionization states. But at the isoelectric point, you will have the net charge of 0, and that will be the average of these 2 values. So we said that the average of 9.6 plus 2.34 divided by 2, that will be 5.97. So at pH 5.97, we will say that glycine will have the sweeter ion or the isoelectric point. It's not like all amino acids will be the sweeter ion at pH 7, but instead it will be at the isoelectric point where all of these molecules will have the sweeter ion.